factor.
Excellent, yes. And find the domain. Brilliant, yes. Yes, yes. That's what I want you to say. Good. So can anyone factor this for us?
X plus 3, X minus 5.
I'm gonna change the problem because I would like to make it even easier. So you said x minus 5 and x plus 3. So this is no longer 43, it's just something I made up. Because I would like to show how the table works with a simple problem, and then we'll look at others. Okay, so can anyone give us the restrictions then for this function?
-3. 5.
Excellent. And now I can simplify, but not before I state this. Because if I simplify before I state restrictions, then I miss something very important. So we always state restrictions and then simplify. So this is, what type is it? Obviously, it's a rational function, but is it type 1, type 2, or type 3?
1.
Yes. It's type 2. The degree in the denominator is much smaller than the degree in the numerator. So it's type 2. Okay, so you already gave me the domain. 0 has to be in the table. -3. Here's what I do. Which signifies the function is undefined. 5 signifies the function is undefined. Okay. And now tell me, what type of points are these with these x values? -3 and 5.
Are they critical? Or
we haven't talked about the first derivative yet, so we don't have anything about the
vertical
first.
asymptotes.
Which one? Careful. Which one?
-3.
-3 is the factor that disappears. So
oh, yeah, never mind.
That's okay. It's okay. Making mistakes help us get where we're trying to go. So this is fine. So this is a whole because the simplified form of the function no longer contains x plus 3. Obviously, x equals 5 is a remaining factor, so x equals 5 must be a vertical asymptote. Right after I identify this, I have to find the limit here, 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 the limit here. So because it's type 2, can anyone give us the limit as x approaches infinity or negative infinity from 1 over x minus 5?
zero.
Very good. We just talked about that. Very good. Awesome. So y equals 0 is a horizontal asymptote. I wrote myself a note. Good. So now let's find these two limits. 2 here, 2 here. Okay. Limit as x approaches -3 from the left from 1 over x minus 5. And limit as x approaches -3 from the right of 1 over x minus 5. Remember this? Yeah, I wanted to, that's fine. Yeah, so I wanted to start from the -3, correct. Remember, this is a whole. These cannot be infinities, not possible. We're talking about the vertical asymptote. Yes, those will be infinities. So what do we get here and what do we get here?
Is it -1e?
Excellent. So the point that is a hole in the graph will be -3, comma -1/8. Perfect. Okay, let's determine that. So limit Sx approaches 5 from the left of 1/x minus 5, and you have to say infinity, but you don't know the sign. And the limit Sx approaches 5 from the right of 1/x minus 5, and you have to say infinity, but you have to give me the sign. How do I know it's infinity? Can anyone give us the sign? You will plug in 4.9, right? And you give me the sign.
Negative.
Good. And you will plug in 5.5, 5.1, and you will give me the sign. That's it. Okay. The only thing that I need here, of course, we always look for the x and y intercepts. So remember the function is 1/x minus 5. So when we plug in 0, what do we get?
Could you repeat that?
Yes, we have to plug in 0. We have to find the y-intercept.
-1.
Negative.
Excellent. Okay, we exhausted everything about the function. I'm done. There is no x-intercept because the numerator cannot be 0. A fraction is 0 when the numerator is 0. No x-intercept. The y-intercept is here. The hole is here. The horizontal asymptote is here. The vertical asymptote is here. There is nothing else. After I exhausted everything here, I can move on to the first derivative and then to the second derivative. Good. So let's look at the first derivative. You know me how I would prepare this function. So again, our function is f of x equals 1/x minus 5. What do you think I'm going to rewrite it as? It doesn't matter. You don't have to. You know, I'm going to write it as x minus 5 to -1 because I always think it's easier than using the quotient rule, but you don't have to. So f prime, I bring -1 in front and multiply by the function to -2 times the inner function prime. But how much is the inner function prime?
One.
Very good, awesome. Now I have the first derivative. I want critical numbers. Critical numbers come from f prime of x being 0 or f prime of x being undefined. Can this be 0?
No.
No. Just please remember a over b is 0 only if a is 0.
But it can be undefined, right?
It can be undefined. So no here, but it can be undefined where? When x equals
5.
5. But this is no critical number or critical numbers. It's no critical number. Why? Because the function is undefined at 5. So remember, this is a critical number when f prime is undefined, but where the function is defined, but no critical number. Now I need to study the sign of this expression. So let's decompose this piece by piece. What is the sign of this? Always and forever? It's something squared, so it's always positive. The numerator is positive, the denominator is positive. So this quantity is always positive, but it has a negative in front. So what is the sign of this expression always and forever then?
Negative.
Negative. That's all I need to do. Now, moment of truth. This and this have to work well together. This is the moment I check and I catch my mistakes. So let's try. From 0 to negative 1 over 8, what does the function do?
Decreases.
Is that supported by the sign of the first derivative?
Yes.
From negative 1 over 8 to negative 1 over 5. So this is negative 1.25 and this is negative 0.2. Is it decreasing?
No.
Yeah.
Wait. No.
Yeah, negative 1.25 and negative 0.2 is smaller. This is smaller than that. And it's going to negative infinity. So it's decreasing, and that's supported by the sign of the first derivative. From positive infinity to 0, so indeed the function is constantly decreasing and forever. And that's supported by the sign of the first derivative. So now, finally, the second derivative. So I differentiate again. I have 2x minus 5 to negative 3. I know I have to finish in 2 minutes or 1 minute. I know. So never 0. So f double prime is never 0 for the same reason like the previous one. And it's undefined for x equals 5, but who cares? So is the function. Okay. So now I need to study the sign. Here is how I will study the sign. I will look at this function like this. And I will not plug in anything in this piece. Why? It's always positive. So, x minus 5 to the left of 5 is negative. To the right of 5 is positive. So the function opens downward, downward, upward. No inflection points because here the function doesn't exist. Here the function doesn't exist and there is no sign change. Okay, so let's look at the time and see if I always run out of time, don't I? Okay, I have 1 minute left. If you allow me.
8:14 right now.
Okay, do you allow me to finish the graph? We're done. Okay, so let's graph it quickly. It's okay if we don't upload anything today. It's okay. I'll change it to next time. Okay, so when we graph functions with asymptotes, we have to graph the asymptotes first. So 1, 2, 3, 4, 5. And this is an overkill because it's already there. No information is important other than my table. I don't care for anything else. My table says this. The function from the horizontal asymptote opens down, decreasing to this point. Okay, fine. So at negative 3, it's difficult for me to graph that, but I'm going to say is this point here. It has to be an open point. Okay, so from approaching the asymptote, opening down and crossing, going through this open point, and then at 0 is somewhere here. So, and then approaches negative infinity. That's what this says. From 0, opening down, going through the open point, crossing the y-axis, going to negative infinity. Done with the left-hand side. The right-hand side opening upward, coming from positive infinity on this side of the asymptote, going to 0. Done. So this is the function f of x x plus 3 over x squared. What was it? I lost my function. Minus 2x.
X squared minus
2x.
2x minus 15.
Very good. And that's it.